A new polymer has intrinsic viscosity of 5.5 centimeter cube per gram and an elution volume of 160 centimeter cube. Based on the method of figure 3.23, what is the molecular weight? Figure 3.23 is a universal calibration graph of eta m, where eta is intrinsic viscosity and m is the molecular weight, versus the elution volume in a GPC. It is based on the understanding that the elution volume in GPC depends on the polymer's hydrodynamic volume. Now, we know from Mark-Huvink-Sakurada equation that eta times m equals phi r0 squared to the power 3 by 2 times alpha cube, where r0 is the root mean square distance, root mean square end-to-end distance of the polymer chain. So, the quantity on the right, which is phi r squared to the power 3 by 2 times alpha cube, is proportional to the polymer's hydrodynamic volume. So we can say that the molecular weight is proportional to the polymer's hydrodynamic volume. And this is the basis of GPC, in which the elution volume is indicative of the polymer's hydrodynamic volume. So in this graph, we see that on the y-axis we have eta times mr, and on the x-axis we have the elution volume. So if you observe the y-axis, the values are 10 to the power 4, 10 to the power 5, 10 to the power 6, 10 to the power 7, and so on, which means that the y-axis is actually the log values, so that if you find the log of 10 to the power 4, it will be 4, 10 to the power of 6 is 6, 10 to the power of 7 is 7. Okay, so we can read them as the log of eta mv on the y-axis. Distance between the adjacent points is 1. On the x-axis we have the elution volume, and this is given as V over 5 centimeter cube, which means you have to multiply the volume as denoted on the x-axis by 5. So if it is 30, then it would be 30 times 5, 150 centimeter cube would be the elution volume. So the line is like this. The eta given to us is 5.5 centimeter cube for an elution volume of 160 centimeter cube. So 160 centimeter cube would correspond to 160 divided by 5, which is 32. And that corresponds to eta of 5.5. So we have to find the point on the y-axis that corresponds to 32 on the graph. So if you look at the graph, the original graph, and if you find out where what the y coordinate of this point is, we'll see that it matches with the value of 5.2. So when I did that, I found that this value here, it matched at 5.2. So let's plug this in. Log of intrinsic viscosity times molecular weight is equal to 5.2, which means log of eta plus log of m equals 5.2. So log of m is equal to 5.2 minus log of eta, which is 4.6. So log m is 4.6. So m is equal to 28,816 grams per mole. So that's the molecular weight.